Okay, let's do it. Built-in fake objects. It's going to be about mock objects, basically, about mocking and mock objects. I'm sure you know what it is, but just, I got this morning from Wikipedia. I decided to remind you what it is. We have classes, we have the code which we want to test, and in order to test that code, we need to create these mock objects sometimes, and not sometimes, but very, very often. And I will try to demonstrate today and to convince you that there are basically two approaches to mocking. One is fake objects, the way I call them, and there are mocking frameworks. So I'm going to show you that mocking frameworks is the wrong way to go, and fake objects is the right way to go. That's the whole point of the presentation. I tried to check on Wikipedia a few days ago whether the name is right, these fake objects, because somebody, like a few people, accused me of using the wrong name, but then I checked on Wikipedia, and the Wikipedia says that different people use different names for that. So there are basically three main names for these things which are mock objects. There are fake objects, there are mock objects, and there are stubs. I like to call them fake objects. I'll show you why. But the main point is not how we call them, but the approach we use, the way we use them. There are two different ways. The one way is mocking frameworks, another way is fake objects. But the goal is the same. We create something which will work for us, which will help us to test our production code. The structure of the presentation is this. First, I'll show you this real example, which is using mocking frameworks. Then I'll show you 4 problems which this approach delivers to us. 4 problems, one by one. The fourth one will be the biggest one. And then I will show you how we fix that problems with the fake objects. And again, I'll show you 4 problems solved one by one and why it's the better approach and why all these 4 problems are gone. And that's it. That's my message. So let's take a look at the code. It's going to be Java. How many of you actually write Java or understand Java? I hope everybody. Okay, that's great. So here's a really primitive production code. You see what it does. So it's like a method, a static method, which accepts a user, an object user, and then it's trying to print a line, to return a line, which says the balance of this user is this amount. In order to print that line, it goes to the user object and retrieves, it gets some other objects from there, and then it gets some other objects, and then it basically gets the balance. So the name comes from there, and the USD, like a balance, comes from there. It's a really primitive code just for the sake of discussion. This is basically the structure, the architecture, the hierarchy of objects. We have the user, which is, they're all interfaces, so we don't know how they work actually. They're all interfaces. So the user has a profile and account, the profile has a name. The account has a balance, and the balance has the USD. This is the hierarchy of objects which, while we are testing our production code, which accepts just the user. I'm using Mockito. You know this library. It's probably the most popular right now in Java for mocking. This is the mocking framework. So remember, first we're discussing the approach the mocking frameworks are offering us to use mocks. So we cannot test this code. I'm jumping 3 slides back. So we cannot test this code without the real user object. So we need some user object in order to test this functionality. So we want to test this function. We want to see whether whether this method works, whether it really prints the text. So we need to give it some user to see what's the return value, what text will be generated. So here's the test, the unit test. I'm using JUnit, I'm using Mockito and Hemcrest. Probably you know what Hemcrest is, what Mockito is, and what JUnit is. So this is a primitive test which creates, the first line creates the mock object with the Mockito framework. And then we call this report method, which we want to test. And then we want to see whether the text returned back contains the string balance of, we don't care what's rest. We just want to see what happens. Another question for you, what do you think will happen if we run that code?
The mocking framework will complain.
No, nothing. Well, it will compile for sure. This code will compile, and then we run it, and then what will happen?
Null pointer.
Say again?
Null pointer.
Null pointer, exactly. The null pointer exception will happen. Do you know where? What exactly will go wrong?
String.format.
So this line, the first line, will create a mock object from this interface, and both methods, because it's created by Makita, it's the way Makita works. So both methods, they will return null. The profile method will return null, and the count method will return null. They both will return null. Because what else it can return? What else Makita makes an object which is like, it's a mock object, so it doesn't work, it doesn't know what to do, and it has two methods. So what else the Makita can do? Makita returns null here and null there. This is the default behavior of Makita. And I think in all other mocking frameworks, this is the only possible default behavior. What else it can do? And what will happen, I'm jumping 2 slides back, and what will happen when this method returns null? Of course, here we're going to have null pointer exception. The same here, null comes back here, and we have a null pointer exception. So that's it. So the unit test is not going to work. Even though it looks somehow okay to us, we created the mock object, but it doesn't work. To make it work, we need to tell Makita what to return in these two methods instead of null, to get rid of null pointer exception. Because the code works, the code is clean, the code is good, but the test is not perfect, the test is not complete. Here's the complete test. So to make this stuff work, we need to instruct Makita, we need to configure our mock object. This user object is not enough to just make it with one call, just mock. We need to make more instructions. We need to create mock profile. We need to create mock account. We need to tell what this mock account is returning. We need to inform Makita. We need to do this testing scaffolding, so-called. So we need to build the infrastructure around our object to make sure that the object looks normal and it doesn't return null. And then we do the same. The last 3 lines of code, the last 4 lines of code are exactly the same as they were before. Well, actually, I added this Jeffrey here and 1, 2, 3 because Jeffrey goes here and 1, 2, 3 is the balance. So I configured everything, and now the user object is smart enough to return the profile, to return the balance, and return some numbers back. And then this test will work. This is the real example. This is the example that doesn't work. And now 4 problems. Problem number 1, it's called verbosity. It's too long. You can see like, look at the production code and look at the unit test. So the unit test is 2 times longer, maybe even 3 times longer than the production code. So verbosity is the complexity, they go together. The verbosity, the length of the unit test is huge when you use Makita or any other mocking framework. The test will be huge, will be long, will be really big. Bigger than production code. Why it's a problem? I mean, it's a problem for many reasons. But first of all, you will just not write unit tests. It will be difficult, it will take a lot of time, it will be difficult to understand this unit test, it will be difficult to maintain that code, it will be difficult to work with this code and to understand what it does. Can you tell, like looking at it just for like half a minute, what exactly is going on here? Maybe you can right now, maybe I can right now, but if you open that code in half a year, it will take you a long time to understand what's going on because it's too long. The code is too long. Because all of this scaffolding takes that much space. The second problem is called code duplication. So, which is, that this is one of the biggest problems for software development in general. And look at these 2 tests. The first one, it's the same code, I'm just trying to refactor it a little bit, to change it a little bit. So in the first code, the unit test is called report includes username, and the second one, report includes balance in USD. So I'm trying to test 2 different aspects of our code. So in the first line, I'm trying to see whether the report contains the name Jeffrey. In the second line, I'm trying to say whether the report contains the dollar amount. So I'm testing 2 different aspects of the same code, which is normal. So we have one production piece of code, and then unit tests are trying to test from different angles whether it works and whether it returns what it's supposed to return. And look how much similar these 2 pieces of code look. So I'm basically doing the same scaffolding again and again. In the left code, in the left unit test method, in the right test method, and I've seen many examples when you have this unit test class, and there are many test methods which are doing exactly the same again and again. So it's a huge amount of code duplication. Why code duplication is a problem, I don't need to explain probably, but I'll say a few words. If you look at this task class, and then there's so many task methods, and then something changes, you have to go one by one and change them everywhere. So you need to maintain many places of code which look identical. And if they're really identical, if you can do like really copy-paste, it's not a problem. It's a smaller problem because you can change it once and then just copy many times. Of course, it's ugly, but that's like half of the problem. But if they're different a little bit, like in this example, they're a little bit different. Here we have this line, we put the Jeffrey there. Here we don't have this line, but we have that line. So this is the only difference in that two lines. The rest is the same. So imagine you have these two methods, these two test methods, and you have to maintain them, and tomorrow something changes, and you need to go through all of them and understand what is the difference and how this little change have to be applied. It's going to be a nightmare. You can imagine that. So this is called code duplication. I've seen many examples. I don't know about you, but I've seen many examples where really the task class is huge and there's so many test methods and they look identical, they look similar. And together with the verbosity problem, with the complexity problem, with the lengths, they're quite long and they duplicate each other. It's just a nightmare. It's unmaintainable code mass. That's the problem number 2. The problem number 3 is complexity by itself. So it's really not so easy to understand what it does. I tried to put some example here in my slide. I was like looking at my code and all I found like production code, like real commercial code, so I wasn't able to put it here. But I'm sure you can look at your stuff if you write unit tests. And you will see a lot of examples when you write the unit test. When you write it, you understand the scaffolding, you understand how you configure your mock objects, and then in a few months you basically cannot understand anything. You need to throw it away and rewrite it from scratch. In my case, there are so many examples, I just didn't find the right code to show you, but if I would show you production code, there would be like 100 lines of scaffolding, and then just one assertion in the end. So we build an object, we configure it properly, we make sure that it returns other objects, and the other objects are configured also properly, and then in the end we just say assert something, and it works. We're so happy it works, we just put it there and forget about it. And then in a few months we just come back to it, we'll look at it, we understand that we don't understand anything, and we throw it away, and if we have enough time, we write it from scratch. If we not, we just ignore the test. You know how they ignore it. We just put the annotations, ignore. They stay there for a few more months, and then we come back and say, who understands what it does? Nobody. Let's just kill it. And we kill the entire test. Even though it was a good test, and just in one line there, we just needed to fix a little bit, and it would work again. But we can't find that line, because it's so long. Like, look at this code. It's quite simple, it's basically primitive, but if you try to fix something, if something doesn't work, it will take you a lot of time to understand it again and again. You will need to look at all these classes, to see how they connect to each other, to look at the hierarchy of interfaces, to understand. So complexity is the problem number 3. But all these 3 problems are nothing compared to the problem number 4, which is called fragility. That's how I would call it. This is the biggest conceptual problem, which I think ruins the entire, it proves that mocking frameworks is the wrong way to go. Fragility means that the unit test becomes too fragile, it fails too much for no reason. It basically, quite often for no reason. Here's an example. Look at this code. It's the same code, production code on the left, the unit test on the right. It works. And then I want to change the way my interfaces are designed, the way the interfaces work. And I want to move this method USD from class balance from interface balance to interface account. I want to do it this way. See the difference? That's all I'm doing. So I'm changing my production code. I'm just redesigning a little bit, which is quite reasonable. I'm redesigning it, and the production code still works because I changed the design of the interface, I moved the method, and I changed the production code. Everything is still fine. The production code is still okay. But the unit test fails. The unit test will fail here, and it will fail for no reason. Because the actual design, the internal implementation of this code, the internal details of this code on the left, which is the internal detail. So the code on the left decides how to use the objects, and it's up to the code on the left to make that decision. But the unit test made an assumption of how the code works. So the unit test on the right, because of the mocking framework, it doesn't treat the production code as a black box. It makes a lot of assumptions of how this production code is designed inside. So the unit test is supposed to look at the code as a black box and test only the external behavior. To give us, here's the mantra of the unit testing. So the unit test has to be like a safety net for us. So the production code is like a black box. The unit test says, I'm expecting you to return number 5. I don't care how you build the number 5. I'm just giving you number 4 and I'm expecting you to return number 5. That's all I need from you. I don't care how you build this number 5 inside. I'm just giving you the input, I'm expecting the output. But in our example, we made a lot of assumptions about how this number 5 will be produced. So we build all of this, we build all this infrastructure, all this hierarchy, all this scaffolding for the object I provide you, and I expect you as a unit test to use it in a certain way. I don't give you the freedom of using it the way you want it. I just expect you to use it the way I want it. I'm the unit test. So I kind of dictate you, your production, you're the production code, I'm the unit test. I dictate you how to use my input in order to produce the output. So you don't have a freedom anymore to make the decisions of the design. So you are coupled, you the production code, you are coupled with me, the testing code. But it shouldn't be that way. And that makes unit tests very fragile. They just fall apart as soon as the production code changes a little bit. The production code makes a different decision of how to produce the result. The result is still the same. The result is still the same. All is happening. I'm just changing the way I'm using the object. I'm just changing the way I produce the result. But I still return you the same text. I still build the same text. But now I don't like your input anymore. It was okay here, but now it's not okay anymore here. So you need to change your test even though my implementation hasn't changed. So the unit tests are not safety net anymore. So unit tests, they have to be, what it means, what this code means, is quite popular. They call unit tests a safety net, which means basically two things. First one is when the code breaks, when I really break the code, when the production code returns a different output for the same input, so it starts to behave differently. It's a positive signal for the unit test that the unit test should fail. The unit test should give a signal that, hey, something changed, we cannot compile anymore, or we cannot test anymore, just stop and do something about it. This is a positive signal. And there's also negative, there's also negative signal, which says that I changed the production code, it still works, it still returns the same output, it still does the same, but in a different way. But the unit test has to say, no problem, I'm not giving anything, it's negative, so you're good to go. So I should have a freedom to refactor my code and rely on unit tests. This is what makes me, if unit tests are designed that way, so I know that they fail when I change something in the wrong way, and they don't fail when I change something in the right way. This is a safety net for me. So it makes my development way more comfortable. I can go ahead way faster because I can rely on them. But if they are fragile, they will generate a lot of false positives. They will tell me that your code breaks, that your code doesn't work anymore, even though the code is still good. So I will not be able to develop in a right test-driven development way, or just not about TDD, but I will not be able to use unit tests properly because I cannot rely on them. They're too fragile. They give too much false positives. So they tell me that the code breaks too many times, even though I don't break it. And it's all of this is happening because of mocking frameworks, because of this huge scaffolding, because when we build this mock object for the production code, we have to configure it completely. And when we configure it, we go into details, we dive into the object and we build the internals of the object. That's the way mocking frameworks work, inevitably. Because they don't know anything about our code. Mockita doesn't know anything about our user interface, about this interface. All they see is just, you have two methods, what can I do about them? I return null and null, that's all I can do. Because it's it's a framework. and then null and null means like nothing will work. So we inevitably have to configure it more and more, and when we configure it more and more, we make it fragile. We make many assumptions. I'm repeating myself. We make too many assumptions about how this code will be used, and we shouldn't. When it leads to throwaway tests, that's the whole point of that. All of these 4 problems, and the last one is the biggest, will lead to tests which are throwaway. So you write them, they become too big, they become complex, fragile, all of this. Eventually you will throw them away and start from scratch. So they will not help you, they will be just a problem for you. You will just waste time. You write these tests, they give you the feeling that your code is good, you feel that the tests work, you enjoy that, you put that code into the repository, in a few months you just open it, they just fail for some reason, you throw them away. But it shouldn't be like that. The unit tests, they should live even longer, much longer than the production code. The code in production you change frequently, but the unit test ideally should stay, way longer, and the life cycle of the unit test should be way longer than the life cycle of production code. Of specific objects. You can refactor, you can change, you can do design, you can move methods, but the unit tests, they stay quite longer, they stay unchanged. Because the unit tests, they represent the functionality you expect from your classes. And the functionality you expect doesn't change that frequently as the implementation of this functionality. So you implement it differently. For example, you have a sorting algorithm. So you have an array of numbers, and then you sort them. And then you write a unit test, which checks that I provide you the list of numbers and you actually can sort them. So the test will stay, for quite longer, but the sorting algorithm, you can change it. You can bubble sort first, you can binary sort next. So you refactor, rewrite your code, but the unit test stays with you for quite a long. It doesn't happen if you use mocking framework. Okay, here's the second part of the presentation. So what's the solution? I think the solution is fake objects. I like call them fake. So the objects, they are fake, they stay together, they are objects that come together with production code, but they are intended to be used in tests. So let's say we have this user interface, and we have this fake inner class. And this fake inner class behaves like a user object. But it doesn't really do anything meaningful. All it does, it just returns profile and account, but not null, but something meaningful. And when I write the code, it will look like that. So I create, instead of using Mockito, instead of using mocking framework, I just say user equals new user.fake Jeffrey123. And then I say build a report, and I expect balance of Jeffrey 123 used. So everything we had before, all of the scaffolding, it's there. It's right there in the fake object. It's encapsulated there, it's implemented there. It comes together with the user, with the interface user. It comes together from the author of that interface. That author, that person, already implemented all that. So I don't need to use any of this scaffolding. I don't need to configure this object. It just comes to me. It's pretty dumb, it's pretty stupid, it doesn't do anything meaningful, it doesn't know anything about the database, it doesn't do any calculations, but it's good enough for testing. It accepts 2 parameters in the constructor. It's a primitive example, but you understand it could be quite more complex. So in my case, it accepts just 2 parameters, and when somebody asks, what's your name, just give me your profile and then give me your name, it will be Jeffrey. And then somebody asks, give me your balance, give me your account, okay, it's $1, $2, $3. That's all. This is my test. Here's the verbosity problem. How long it is, how complex it is. It's quite simple, right? Anybody would understand it in a year what it does. In a year, you will open this code and see, okay, I understand, it's a fake user, it's not a real user, it's not a user from the database. Okay, what I'm testing how the report actually can build a report if there is a user. Does it work? Yes, it does. Did we solve the verbosity problem? Yes, we did. The second problem, code duplication. We have exactly the same 2 situations. So on the left, I want to test whether the report will include the username. I create the fake user with the Jeffrey. Well, the constructor will accept, which will accept Jeffrey. Does it include Jeffrey? Yes, it does. On the right, we create the same fake object, but only provide the number for the balance. And we check whether the balance is there. The code is, there's no code duplication in here. It looks similar, but you can, we don't really copy-paste. We write that code from the left to the right. It's different pieces of code. We don't duplicate scaffolding because there is no scaffolding, no this long list of building the structure to test. So the second problem is solved, code duplication, I guess. The problem number 3, complexity. Do we solve the complexity problem? Well, yes, I think it's quite easy to understand what's going on here. It's short. And even, like, I'm using this approach in production in a number of libraries where these objects are quite complex, these interfaces. So you need to build it, and it takes some time, some lines of code, but even in that case, no matter how complex they are, this initial construction of the object to test, of this mock object, will take 3, 5, 7 lines maximum. That's the maximum I've seen. Because there's no weird, these Makita calls, which is so difficult to understand. Everything is encapsulated in the fake object. And the fake object is quite smart. It actually built to help me, the developer, to construct this test infrastructure. So if it's becoming too complex, I can improve it and make it even simpler, so I can accommodate it for the different users in tests. And the problem number 4, which is definitely solved here, the problem of fragility. So if the code on the left changes the design, and we change the design of this user balance, we move the method, then the code on the right doesn't need to change anything. Because all of these details of how it's implemented will immediately affect the design of this class. Because the author of production code will also update the fake object, because they go together. They are shipped together. The designer of the user interface, of the interface user, the designer of that interface will design the fake class as well. And that fake class, of course, will know about all the changes that happen there. So they happen there, we make the changes in the production code, we make the changes with the fake object, and all of our tests immediately work as well. So they don't fail, they don't give us false positives, they don't give us false signals, they don't break. Because we change production code together in the same time when we change fake objects. So what we'll have in the end as a result is that we'll have no throwaway tests anymore. So you write your tests and they will, like I explained, they will stay with us for quite a while, for a long time, because they're not fragile anymore. And that's the main problem, which, this throwaway test is what makes unit testing so unpleasant activity for many developers, for me myself as well. So I was using Makita for years, and I thought this is the right approach because I learned a lot about Makita. It's quite a powerful library, and it's quite well designed library. If you work with it, you know that it's probably one of the best, and definitely the best for mocking. But the more you work with that, the bigger your code base is, the more complex is the hierarchy of your objects, the longer your tests are, the more complex they are, and the more of them you throw away eventually. The more of them you throw away. You waste your time, and then eventually you will just stop writing unit tests. Because you will just realize that I write it today, and in 2 months I just throw them away. With this approach, when you make fake objects, your unit tests will be small, will be short, will be easy to understand, will be friendly for maintenance. And I'm finishing. So you have to always, I think, ship them together. That's one of the last points, not the last one, but the last point I want to make is that it's better to ship them together. So in my design, I do it this way. They go like inner classes. So every time I create an interface, I put the inner class in there, which is like in this example, which is the fake object. So they want to stay, my point is that they want to stay as close to each other as possible. So every time you design a production code, think about people who will use your interfaces for their code, and always give them the fake class. Here's my interface, here's my fake class. When you design a library, absolutely a must to give the fake class. Because if you don't do that, if you just deliver the library where you have interfaces and classes that implement that interface, or just classes, and then you give that library to me, I don't have fake objects from you, so I will have to create them. If you, for example, give me the interface user from your library and the interface balance and the interface account and profile, and they just come to me, and now it's time for me to work with your interfaces or with your classes, and then I need to find this fake object somewhere. I will have to write them. It's going to be, some extra work for me, which I don't want to do when the library is coming from somebody else. If it's my library, okay, I understand. This is my code. I put like fake classes on top of that. I kind of see the value of that. But if the library is coming from somewhere, I'm not interested to write these fake classes for somebody, for third-party library. And I will inevitably use mocking frameworks, which will make my life, more difficult. So every time, if some of you actually write open source libraries or you write code for your other projects, so you work on one project and then some other project consume your code and reuse your code and integrate with your code. So always try to give these guys fake classes together with your production classes and interfaces. I think it's important. So here's the summary. We have mocking frameworks, we have fake objects. No mocking frameworks, only fake objects, for the reasons I just explained. A little bit promotion. I have a book called Elegant Objects. It's about object-oriented programming. And there's a chapter, there's a section 2.8, which explains what just said here, but with a little bit more words. And the title of the section is Don't Mock, Use Fakes. It says exactly, I just explained here what the book says. So I would recommend to take a look at it, to buy it, and read this section, and all other sections. So that's basically it. Let me know what you think. Is it in line with what you see in your work, with your unit testing practices? Yeah.
Isn't it intrusive to have the fake objects in the production class or interface?
So the question is whether it's okay to ship the interface, the small interface, and then a huge class which is for testing only, right? Together with production code. That's the concern.
I think the example you have is you have the class fake, which is in the interface that is the production.
Yeah.
Right? So that means that you have something that is tests in
production code. Yeah, that's a good question. So the question is, we combine test code with the production code, and we deliver them together. Like in Java, it will happen inevitably. So you will create this jar library, and inside the jar library, we will have interface user and the fake class, which is not the production code, which is for unit testing only, but it will go together and will go to production platform. It will be deployed together with all other classes. Well, I understand the concern. I think it's valid, of course, to call it a concern. But in my practice, when I started that, I also had the same, like, is it really good? And actually, when I started going that direction, I was creating two libraries always, two jar files. The first one with all these interfaces and classes which are production, and then the separate jar file which contains only fake objects. That was my initial strategy. But then I realized that quite often, these test classes, these fake objects, could be used in production as well, not only in unit tests. So it will be possible, sometimes you will need them. And I can give you a number of examples. For example, let's say I had that a few months ago. We have a product which connects to GitHub, and then on GitHub it opens the issue, like the discussion issue, and by the number. So we get a number somewhere, like issue 123, and then we go there, we connect to GitHub through RESTful API, and then we have an object, which is called issue. And sometimes, the issue is gone. So somebody gives us the number 123, we go to GitHub, and it's deleted over there already. But we don't want to fail. We don't want to crash, because when we retrieve the issue, the code which uses this issue object just needs a number from it. So the number comes in, and then we retrieve the object called issue, and then the code checks the number, and in most cases doesn't do anything else. I mean, it uses just the number. So when an object is absent, so what happened first, we connect there, we go there, we don't find it there, we throw an exception. Everything breaks. But we realize that we don't need to break all the time. In most cases, we can just return a fake issue, which has a number, and that's all. So it has a number, but if you go deeper, you will find nothing there. No comments, no text, nothing. Which in most cases, in our business situation, in most cases was not a problem. So we were, instead of throwing an exception, we were just using the fake issue and returning it back. And saying, yes, the issue exists, the number is 1, 2, 3, but that's it. With an empty title, with an empty text and everything. So that was, let me finish. So that was the purpose. And I can find a number of examples like that, where the fake class was perfectly fit for production code. So, yeah.
I think you are mixing concerns. The example you are giving to us is like introducing some kind of caching by misusing your test class. So the behavior you describe is something like, oh, I should store this ID for some error situation, and I should do it as a clear step in saving it, and not using something I have there by incident because some genius built it in for testing.
Well, yeah, you're saying that that what I just explained could be done in a better way. It could be done differently. You're saying, yeah, it could be done differently.
Explicitly.
Well, yeah, explicitly, yeah. But I think, well, we're trying to work with objects in most cases, and we're trying to represent everything as an object. And for us, in our design, it's better to put the functionality of making the decision what's happening, of what the situation, and then return something, not letting know everybody else that the error happened, that the mistake happened. So instead of just spreading this error handling code everywhere and letting these guys decide what the situation, whether the issue existed or not, that we need to cache this ID somewhere and just rely on the ID instead of the full issue, we just encapsulate this whole functionality and an error handling code right there, and then we return something which is just a fake thing. I'll try to give you another example. Maybe it will be easier. Let's say, well, I'm always like thinking about this case for the GitHub, because GitHub is, yeah. Well, we have another story. Also, we had an issue, and then when you go through the comments in the issue one by one, sometimes again GitHub sometimes delete the comments, but you still have the numbers from them. So GitHub informs you, like, somebody just posted a comment in there, and here's the number of the comment. And when you go back to GitHub, the comment is already gone. So the notification just arrives, and then in a few minutes it's gone, and you go back there and you're trying to retrieve this comment. And for us, it's enough to say that if the comment is gone, it's empty comment. That's all. So we just do processing of comment by comment. We're just analyzing what people are saying, and we just go one by one. And if it's empty, we just ignore it and continue and continue. So we're basically looking for some keywords in this comment. So we go to GitHub and say, okay, give me the next one. Give me the comment number 5, and then 6, and then 7. And they return it in text. And every time we encapsulate it, we call it a comment object. And then it gets here, and the processor, the analyzer, analyzes what's inside. But then eventually we go there and telling GitHub, give us the comment number 7. But there's nothing, it's gone. It's an error coming back. The HTTP exception. So the comment doesn't exist. So we understand, okay, if it's an exception, we create a fake comment with an empty text and return it back. That's all. So if I wouldn't have this fake object, I would create it. If I wouldn't have it shipped to me from the library, I would just create it myself here in my code. I would not return, because these guys, they accept the comment object from me. They don't expect the text from me back. They expect an object. So I need to return an object to them in order to completely, I don't want them to know that this situation can ever happen. And that's why I return the fake object. So it really saves me from making this class, from writing this class from scratch in my code. Because somebody else may have the same situation in their own code again and again. And I'm talking about library for the GitHub connectivity. So I have an open source library in GitHub, which people use. There are over 200 stars there, so there are many users who use this library. And that library contains interfaces for all the things in GitHub, about 100 interfaces. Comment, issue, commit, everything, pull request, all of these things which GitHub API provides. So we have 100 interfaces, and we have 100 fake classes. So we ship this whole thing, so I'm answering your question, so it really makes the library bigger, of course. So we have 100 interfaces and 100 fake classes and 100 real classes. So we have 3 hierarchies of objects. Interfaces, real classes, and fake classes. And we ship them to all our users. And I'm sure that some of them actually using this fake stuff in their production code as well. Of course, they all use it for the fake, for the testing purposes. And I can tell you that the design of these fake objects will sometimes and very often take more time than the design of production of the real code. So to build, like in this example, one second, with this example with the GitHub library. So we have 100 interfaces, we have 100 quite simple classes to connect to GitHub and return back something, because it's just a primitive RESTful API. You just connect there from GitHub, you return back the JSON, you parse that JSON, and you return an object back. It's quite easy. But we also provide 100 classes, which are fake classes, which people can use in their code and say, create me a fake GitHub API. And then I go to GitHub API and I create an issue. And then I can retrieve that issue. So we actually build a kind of a database, a fake database, which help people to test their code against that fake GitHub API. So you can get that GitHub code, you can instantiate it, and it will look to you like a real GitHub server. You can imagine how more code it includes comparing to production classes. Yeah, probably that was before. Yeah.
So your example with the HTTP error on GitHub that resulted in a fake comment.
Yeah.
That will work well because you know at this point in time your code will only assume that this is a comment. Okay, now developer 2 months later comes along, he changes his code, and now he wants to say retrieve the comment number, and he doesn't know anything that about that you have fed this method with a fake object instead. So now the code will break. He doesn't know that you have fed the method with a fake object and not a real live object.
Yeah, I understand what you're saying. Yes, so you're saying that, for example, now
So the problem about maintainability has just now been pushed into production code instead of your unit testing code.
Yeah, that's a good point. Yes, so you're saying that when I'm designing production code and I return my fake objects instead of real objects, and the production code, all other code doesn't know about that, they still rely on the object. They think it's a real object, they think it's a real comment, and in the future they may start using it in a different way, and they will hit an exception or something weird behavior, right? A strange behavior. Well, that's a good point, and it may happen. Indeed, we haven't seen it yet, but it may happen. And I think for that reason, these fake objects have to be designed in a way so they don't behave in a really weird way. So they have to be designed to throw the right exception in the right place if something really wrong is happening. But if I'm saying it's an empty comment, it should be an empty comment. It shouldn't be the comment like, "Hey Jeffrey, it's hello world." It shouldn't say hello world if it's empty, because when you design fake classes, you may put some random text in there because you think it's just for tests. So who cares? They put hello world, they put random numbers, they put whatever, because it will be perfectly fine for tests. But it shouldn't be like that. So think about the design of these fake classes even more, with more attention than you put into production code. Yep, probably that one.
Yeah, I'd like to argue the point that the problem was in the production code from the beginning.
Mm-hmm.
You were violating the law of the meter, which means you shouldn't call a method another object and the methods on that object and the method on that object. This is what leads to the Mockito hell, when you have this nested method call.
Yeah, I checked. That's a good question. I'll repeat it. So the point is that here, the mess we had is caused actually not by here. So all this, Mockito hell, like a lot of scaffolding and a lot of this code we see it here because the hierarchy of our objects is too complex. Because we're getting objects from objects, and that's why, in order to get the balance of the user, we need to jump through 3 hoops. We need to see 3 different objects. And there's quite famous law of Demeter. Who knows about that? Law of Demeter. Okay, so you heard about it. So this law, if you read about it in the articles, you will see that many people interpret the law as if it says that this method should stay in the user interface. So we have to have, this is what people think about the law of Demeter. that it says that all the functions, all the methods, they should be shifted as left as possible. So they all should stay together in one class, in one like user, for example. But I have a blog post about that. I analyzed this law of Demeter. I read the original article when it was like written like I don't know how many years ago, and I think that our interpretation of this law is wrong. I don't think this law says that we shouldn't have objects coming from objects coming from objects. I think that law, and I have this blog post about that, so I analyzed this law, and I think this law says that we shouldn't have property dot property dot property dot property. So having the direct access to attributes by dot, by dot, by dot, that's what the law of Demeter is saying. That's what's wrong. That's what causes problem with maintainability and all of that. But accessing objects from objects has nothing to do with the law of Demeter. And you can check my article, it explains what's wrong. So I think this design is right, that's my point. So I think this design is right, that's how it should be. The objects should be small. Because if we interpret the law of Demeter like that, if we think that we shouldn't use objects from objects, we shouldn't use these multiple steps, then all our objects will be huge. We'll have a lot of methods in all of them, which is, I think, against object-oriented
You
programming.
could consider introducing a new class that contains the information you need, perhaps.
Yeah, probably. We can discuss it a little bit later. I'll show you the article, which is quite an interesting point. Yeah.
Aren't you just using a framework that handles recursive modeling? They exist in C# and I assume Java has them as well. Then all this will change to the lines of code.
If I didn't get it, so
It's called recursive modeling, and then modeling frameworks most all objects under the first object.
but how? Yeah, you're saying that there are some frameworks who can do recursive mocking. So they will do the scaffolding for me.
No,
But how technical they will know about this? Say, for example, Jeffrey.
not all of this.
Is it possible? So they will make sure that there's no null return there. Yeah. So they will return something, some more objects. But uh-huh. I haven't heard about that. If they exist, I mean that would be great. That would be better, of course. Yeah, that will solve the problem with complexity. That will solve most of the problems. But still, I think that the fragility problem will not be solved. Because still we will make the assumption about how our production code behaves will still be made on the level of unit testing. We will still make the assumption this code, even if it will be like shorter, if it will be just 3 lines, we will solve all the previous 3 problems: complexity, verbosity, and code duplication. They will be gone. But the problem of fragility will stay, because still the unit test makes an assumption of how this code behaves. Even if I say it is just 1 line of code, I will say when the .usd, when the user.account.balance.usd is called, return 1, 2, 3. That will be short, that will be just 1 line. That's perfect, that like solves many problems. But still, the last problem stays. I still make an assumption about how the code behaves inside. It's like, it's like, let's say, let's make a simple example. We have a sorting algorithm. So I have a sorting which does the bubble sort, for example. And then I write the unit test. And in the unit test, I'm saying, when you sort, I expect you to call that and that, functions when you do bubble sorting. That would be just wrong, because the unit test makes an assumption that the bubble sorting is used. And then I switch it to binary sorting, and it will be just gone, and the unit test will break. But why do you break? It still sorts. You see, so that's the main thing. The question over there. Yeah.
Yes, I was wondering about configurability of the fake objects. If you want different behavior at different times, do we have a strategy for that?
So the question is, how do we configure these fake objects, and how powerful this configuration is? Yeah.
Yeah.
Well, in our case, in some libraries, we have really powerful, really powerful methods to configure them in different ways, because we understand that that again, like I said, people will use that stuff even more often than they use production code for their unit test. So sometimes it's really simple. Sometimes it's just like that. Just a similar primitive constructor. But very often in our libraries, we have build-up pattern. We have these fluent interfaces to configure something which is the fake, which is for the unit test. And it becomes it becomes even more complex and even bigger than the code by itself, than the production code, if we are talking about the library. So when you design a library, you make a number of interfaces, then you implement that interface and you ship that library, and then you ship together with that, you ship a number of fake classes. And then you will see the more people will use that, the more they will start using your fake classes, the more complex it will become, and you will deliver them more and more and more. You will write, and your code will stay because there's not much to change. For example, I have a library which is an HTTP client. So HTTP client is, you know what an HTTP client is. So it just makes a request and then returns back the result through the HTTP protocol. It's quite simple, just a few files of class. And then in that library, I also provide a fake server. So that the people who test that client, they also need a fake server who will be able to, to reply something back, to return something back to them. And it's way bigger and it's way more powerful in configuration. And I can give you more examples of that. It's just my personal experience. It always grows inside and becomes bigger and bigger. I think we're finishing. Yeah? Yeah, thank you very much. Thanks for attending.